Right, welcome back to HSB class. So today we'll be looking at the respiratory system. Today is part 2 of what we started last time. We are looking at breathing today, but particularly I'll be looking at vital capacity and lung capacity. What is it that you need to know about the capacity of the lungs? Right, so you would have looked at the lungs and several things that affect breathing. So we are going to look now at some things that affect the capacity of the lungs. In other words, what causes the lungs to be able to hold the amount of air that it does, and what are the different quantities or amounts that it can hold. On screen now you're seeing a pictorial graph that shows different capacities of the lungs. You notice for most of the graph there is this continuous up and down, which is almost the same for most of it. We would refer to this as the tidal volume, and tidal brings to mind the sea and the fact that it's flowing back and forth for most of the time at the same level. So tidal volume is the regular amount that we breathe in and breathe out. The regular breathing capacity. That's normal. That's what we normally do. So that's tidal volume. In addition to tidal volume, we have what is called inspiratory reserve volume. Inspiratory coming from the word inspiration or to breathe in. So once you see inspiratory, you know we're talking about breathing in. Reserve volume means reserve is something that's not normally used. It can be used but not normally used. So this is basically the breathing in, the capacity that we don't normally use when we are breathing in but we can use. So basically, if you should really try to breathe in, you would use up what is called your inspiratory reserve volume. We don't normally use it because we normally use the tidal volume, but the inspiratory reserve volume is there. It's the capacity that we can use if we really try to breathe in. The opposite of that would be, of course, expiratory reserve volume, which is coming from expiration or to breathe out. It is that amount which you could guess based on the fact that it's the opposite of inspiratory reserve volume. It's that amount that you can expire or breathe out if you really try. It's more than what we breathe out in the tidal volume, but if you really try, you can reach the capacity of the expiratory reserve volume. You will notice below that there is the residual volume. And when we talk about residue, if you have some drinks in the cup and there's a little bit remaining, we call that the residue. And you're mixing something and something remains in a container, we call that the residue, or what is left behind after you would have gotten rid of most of it. So residue is what remains, but you notice that there is no residual volume for inspiration, only for expiration. So residual volume basically is that amount that remains, that even when you try your very best to breathe out, there is that small amount that remains. You notice it's a small amount, takes up a small portion of the graph. That small amount that remains after you try your very best to breathe out everything, that is called the residual volume. So the fact that there is none at the top, uh, as it relates to inspiration, there is no residual inspirational volume. There is only residual volume for expiration. That tells you that it is possible to fill your lungs to the maximum by breathing in, but you cannot completely empty your lungs. There is always that little bit that remains in your lungs. Very small amount, but compared to the capacity, but there is a small amount that remains at all times. It's very hard to completely empty your lungs. Alright, so We want to focus primarily on what is called vital capacity, and vital capacity is, as the name suggests, a measure of what, well, when you look at the graph, you can realize that it takes into consideration not just the tidal volume. The tidal volume, you see the line, the arrows extend from the expirator reserve volume to the top of the inspirator reserve volume. So it takes into consideration inspirator reserve volume, tidal volume, which is the normal volume, and expirator reserve volume. So vital capacity is a measure of the maximum amount of air that you can breathe out after you take in maximum breath. So after you fill your lungs, you take a deep breath and fill it as much as possible. And then you release as hard as you can and release everything for as long as you can. That is called vital capacity. Vital capacity is the maximum release from the lungs after you would have taken in maximum breath. So you take in as much as you can and then you let out everything that you can. That is the vital capacity. Vital capacity is essentially all that you can breathe out, but you must have taken in all that you can take in to reach a point where you breathe out everything that you breathe out. Because if you're operating at tidal volume, you wouldn't be taking in everything that you need to take in, because we know that there is the inspirator reserve that would not be a part of the tidal volume. So when you take in your regular plus all that you can take in and then you let all of that out, that is called vital capacity. So how do we measure vital capacity? There is an instrument that is used to measure vital capacity, which is called a spirometer. Some call it spirometer or spirometer. So that is what we use to measure the vital capacity of the lungs. It's basically, here it is, a machine connected with a tube in which you insert the end of the tube into your mouth and breathe in and out to get the regular breath, and then you take a very deep one to fill your lung to maximum capacity and release everything that you have. So of all the things that we would have looked at, inspirator reserve volume, expirator reserve volume, and right, and residual volume, the only one that is not involved in measuring vital capacity would be the residual volume, and that's for obvious reasons, because you cannot release everything from your lungs. So the residue will always remain even when you're measuring the vital capacity. So it doesn't take into consideration the residual volume. It's not included in measuring vital capacity. So this machine would measure the vital capacity, and you realize that the person's nose, the patient's nose, is clipped, because if you're going to breathe into the machine using your mouth, you don't want air escaping through your nose or air coming in through your nose. You want to measure exactly what is being released, and if you're releasing some through your nose, it's not going to completely measure accurately what is being released. So that is a spirometer, and the process is called spirometry, as you can see. So spirometer is used to measure vital capacity, and this machine can tell us many things about us. You would have looked earlier in the previous video on things that affect the breathing rate. So if your lungs are sick, the readings on the spirometer would determine that there's something wrong, why you cannot breathe out as much as you should for your particular age, gender, and those things can tell that something is wrong with your lungs, such as lung cancer, or there's a deficiency in one lung, or anything that severely affects your breathing rate. So that is it for vital capacity. and how we measure vital capacity. Remember, it's a combination of the inspiratory reserve volume plus the regular tidal volume and the expiratory reserve volume. Vital capacity is the maximum amount of exhalation that you can do or breathing out after you would have taken in maximum breath. And we measure that using a spirometer.